Guys, welcome back. So today what we're going to be looking at is integration using partial fractions. So if you haven't already seen my partial fraction decomp video, please go and check that out. The other thing that we need to make sure of is that we need to make sure that when we are using partial fractions that the numerator is smaller than the denominator. So in other words, it's a proper fraction, not an improper fraction. So I'll give you an example of something that would be like an improper fraction. If we had something like x squared over x take 1, x squared, it's a higher power of x, so therefore it's going to be larger than my denominator. And so I would have to go ahead and I would have to perform some long division in order to get the quotient and then the remainder. And now that I have this in a more simple form, then it's going to be a lot easier for me to integrate. So just a couple of tips to keep that in mind if you are doing partial fraction decomp. Okay, so let's have a look at some of these really sort of simple, familiar type questions. So these ones here, we actually don't have to work out the partial fractions. It's just asking us to perform some of the algebraic processes that are involved with partial fraction decomposition. So just as a refresh, when we've got something like this, what we want to do is we want to choose values of x that are going to either remove my a term or remove my b term. So in other words, I want to find when x is equal to 0, because 0 times a will remove that a term, and then I can find the value for b. Similarly, if I substitute in x is equal to 1, then substituting that into here, b times by 0 will be removed, and then we'll just be able to deal and determine the value for a. So I'm going to go ahead and substitute in x is equal to 0 first. And this is a pretty straightforward one, so I've just gone ahead and I've determined that the value for b is going to be equal to 2. Now I'm going to substitute x equals 1 into my equation, and that's going to eliminate the b term, and I will solve for a. Now that I have each of these values, I can substitute those back into that original expression. But we're not going to do that today because we're not trying to integrate for this question, so I'll just leave it and I'll move on to the next one. So again, for this one here, we're not actually trying to do any integration just yet. So we're just trying to substitute in values of x that are going to cancel my a term, my b term, and my c term. So for this one, I'm going to pick x is equal to 0, and that will cancel out that term. I can also choose x is equal to -3 because that will cancel out my b term, and then I could choose x is equal to -3 and that will cancel out my c term as well. If I do x is equal to -2, that's going to cancel out my c term and my a term, so I just have my b term left to deal with. So I'm going to go ahead and substitute those values in. All right, so I've gone ahead, substituted those values in, and I've solved for A, B, and C. So if you want to take a screenshot to see what I've done, this is pretty straightforward, just substitution of numbers to find particular values. So we're not at the integration part yet. Now here we go. So here's an example of some integration using partial fraction decomposition. So you'll see the similarities between the above two little questions that I've done and this question here just in a moment. So what I'm going to do, so again, if this is more than just a little bit of a refresh for you, if this is a lot of new information, you should be going back and checking out that previous video. So what I'm going to do is I'm going to rewrite this using partial fractions. So if I have a over x minus 2, so this is one of my factors, plus b over x plus 2. And what we want to do is we want to find the values of a and b now. And so in order to get these to add together, they need to be like fractions. So in other words, we need to cross multiply so that they have the same denominator. So this is going to become a x plus 2 over x plus 2 times by x take 2. So same as our original denominator, plus b times by x minus 2 over x plus 2 x minus 2. Okay, so lastly, what we want to do, remember this is going to be equal to 12 over x minus 2 x plus 2 here. And so what we want to do is if we multiply the entire thing now by the denominator, we're going to only be dealing with 12 is equal to a x plus 2 multiplied by b x minus 2. So what we're going to do is we're going to substitute in those values of x that are going to eliminate one of our variables. So let's test x is equal to 2, and that will eliminate my b term to solve for a. And then let's test our x is equal to negative 2, because that will eliminate my a term. So let's go ahead and substitute those values of x in now. So just like we did before, nice simple substitution. So this is where we're actually going to get some value out of doing this partial fraction decomp, because what we're now going to do is I'm going to put my value for a in front of this fraction here, and then my value for b in this fraction here. And so if we wanted to find the integral, hold on, I just might scroll down. If we wanted to find the integral of 12 over x minus 2 times by x plus 2 dx, then that's the same thing as finding the integral of, now what was our value for a? 3. So the integral of 3 over x minus 2 dx minus the integral of 3 over x plus 2 dx. So this is why we use the partial fractions, because I'm sure that you can appreciate that the integral of these two functions are now going to be very simple. So when we integrate anything of the form 1 over x, that's just going to become ln of x. So this is going to become 3 lots of ln x minus 2 minus 3 lots of ln x plus 2 plus c. And we could go ahead and we could probably simplify this further using our log rule. So let's go ahead and do that. And there we go. That is now our solution. So all I've done, just to clarify, is I factored that 3 out the front of both of my terms. And then when we subtract logs, that's the same as dividing one function by the other. So that's how I got my final result for that question. Let's jump in. Let's do one more of these simple familiar type examples for partial fraction decomp. So again, I'm going to say a over one of my factors, so a over x take 2 plus b over my other factor, x plus 1. Now, in order to get these fractions to be like terms, so because we are trying to add them, we're going to cross multiply so that we have a x plus 1 over x plus 1 x minus 2, and then same thing for b, we're going to cross multiply over x plus 1 x minus 2. And so this is going to be equivalent to 3x over x take 2 x plus 1. Now, if we multiply the entire equation through by the denominator, we're going to get 3x is equal to ax plus 1 plus bx minus 2. So let's choose values of x now that are going to eliminate one of the terms. So if we let x equal to 2, that's going to eliminate my b term and I can solve for a. If I let x equal to negative 1, that's going to remove that a term and I'll just be left with the b term. So let's go ahead and let's substitute and find our values for a and for b. So I've got my value for a and b just through substitution. Now what we're going to do is we're going to substitute this a is equal to 2 into this original function and b is equal to 1 into this original function here. And then we'll go ahead and we'll find that integral. All right, just substituted back into that original equation. So let's go ahead now and let's find each of the integrals of our partial fractions. So our first integral is just going to be 2 ln x minus 2. Got to make sure we do the absolute brackets as well because we can't take the log of a negative number. And then we've got, and then we've got our log natural of x plus 1 as well. Okay, so that is how we use partial fraction decomposition to integrate functions. I hope you can appreciate why it's really important to use these partial fractions. It actually makes the problem a lot more simple to deal with. So if you haven't gone ahead and you haven't practiced partial fraction decomposition, go ahead and get really comfortable with that first, because really partial fraction decomp is not tricky once you've practiced it quite a bit. It's a very algebraic process. Alrighty guys, I'm going to leave you off there. I'm going to jump into the next video and we'll be looking at complex familiar type questions for solving integration using partial fractions. See you in the next one. Bye guys.